lesson here. An angle consists of two different rays that have the same initial point. So here's our initial point here, and you can see the two rays coming in, but they meet at that one point. That's called the vertex. The rays are the sides of the angle, and the initial point is the vertex. So if we're going to name this angle here, there are several ways to name an angle. When you're using 3 points, you want the middle letter, okay, to be the vertex. And then this one here is with one letter, which is the vertex again. You can go BAC or CAB, but A in the middle, okay? Okay, how many angles do you see here? There are 3. There's the little one here, MNP. The other little one, PNO, PNO, or you can see ONP as another way to name it. And then the big one, MNO or ONM. Okay? Question. Why should you not use angle N to name this angle, or to name any angle in this figure? The reason is because notice how many angles there are that's using that vertex N. And if you only name if you're only using N, it could be confusing. Which one are you talking about? Okay, so pay attention to this. The expression M, that symbol A, is read as the measure of angle A, where M is the measure, this symbol, angle. The tool used to measure angles is called a protractor. Okay? The units used to measure angles are called degrees, and the symbol for them is a little o. It is in the exponent position when you write your number for the angle, and then you put that little o in the exponent. Okay. When you are measuring with the protractor, make sure you put the vertex in the center of the protractor. You want to line this side up with one side of the angle and have it line up with the 0 on this side. Okay? Now, when you're reading the protractor, on this side, you want to read the outer scale from left to right. So it's this outside scale. Notice it's going from 0 to 90 to 180 on the outside. Okay, now we're on the right side, and we have the side of this angle, vertex, and it's being lined up at the 0. But the 0 in this case is on the inside, and you read right to left. We have several angles here. Okay, let's take a look at the angle here. Notice We want to be on the outside where the 0, we want to line this up and get to the vertex. We're finding the angle QSR. Remember, S is the vertex, it's in the middle. Okay? All right, so over here we're going to be measuring the angle, or we're finding the measurement of angle MST. So here's your vertex. Okay, so from 0 to 45. And then we have QSY. QSY. S is the vertex. We're finding this angle right here. It is also 45, so we have two congruent angles, MST and the QSY. And since they are equal, we say that when angles are equal, we say that they are congruent, and the equal sign mean the same. Okay. For any point A on one side of, and this should be a ray. Notice right here, we have two arrows. That says a line. What that means is that it's going in both directions. Clearly, it's only, this is a ray, so I should have had one arrow pointing to the right, like this one. So ray OB and ray OA can be matched 1-to-1 with real numbers from 0 to 180. And what I mean by that is right here. So if we took the 60 that's here and the 140 here, we want to subtract those two numbers. Now notice that when you subtract 60 minus 140, you'll get a negative number. We cannot have negative numbers for angles, nor can we have measurement numbers for length. So measurement of angles and lengths of segments cannot be negative. So we use the absolute value to make sure it stays positive. Okay? And then you can do the same thing over here. Notice down here we have 120 and then the 40. You can subtract those, get the same thing. Have interior and exterior. The point that is between points that lie on each side of an angle is in the interior of the angle. And of course, the point that is not on an angle or is in its interior is in the exterior of the angle. It just means it's on the outside here. Okay. And then in the above diagram, A is in the interior of the angle and B is in the exterior of the angle. P is in the interior of angle RST. Okay. Then we can say that the measurement of angle RSP, this angle plus PST must equal the big angle, okay, which is RST, all this in purple, okay? Okay, so that's leading up to angle addition. Okay, so name the angles in the figure, practice doing this. So angle CDE there in red, or you can go the other way, EDC. Again, over here in blue, EDF or FDE. And then the bigger angle, right? CDF or FDC. Okay, so in the figure above, the measure of angle CDE is 62 degrees. There's the degree symbol up here in an exponent. And the measure of angle EDF is equal to 18 degrees. And we want to find the measurement of angle CDF. Okay? All right, so here is geometric notation. The big angle, CDF, is equal to the two smaller angles added up. And then substitute in, add, and get your measurements. Now we want to name the angles. Classifying is another way of saying name the angles, and we have 4 types of angles here listed here. Over here, to be an acute, you should have remember this from earlier years, that it must be less than 90. The right has this little square in the corner. That means it must equal 90. Obtuse has to be less than 180, and straight will equal 180. It doubles the 90. It's like turning that all the way to the left, creating a straight line, 180. Okay. Okay, 2 angles that share a common vertex and side but have no common interior points are called adjacent angles. Okay, so we have adjacent angles here. Here's the common vertex, and here's that common side that is being shared with these 2 angles here. Okay, so to name the 2 adjacent angles, we must identify the vertex that's common and the side that is the same or being shared by 2 angles. Okay, all right, so here we go. ADB or BDA, all right, ADB or BDA in red, and CDB or BDC are the 2 adjacent angles. The common vertex, D, and the common side, DB, the ray DB. Okay, so we want to use a protractor to draw 2 adjacent angles, angle LMN and angle NMO, so that angle LMN is acute and angle LMO is straight. Okay, so LMO, we know it's 180 degrees. The acute angle is less than 90, measures 40, so that angle is 40. This is an obtuse angle. It is 140. Okay, so we're going to classify the NMO, angle NMO, as acute, right, obtuse, or straight. Well, NMO is obtuse because it's greater than 90, but less than 180, okay?